So let's take a step back before we actually dive into the technology and what it is that is SDN. And we need to ask ourselves some questions. What is the most important thing about SDN? Is it the what? Now, there's lots of conversation in the vendor community about what an SDN is, and we all have a lot of different definitions of what fits into that SDN bucket. Do we talk about the how? How do we build SDN? Is it open flow? Is it not open flow? What APIs are we using? Or is it the why? Why are we building SDNs? And it's the why that's the most important point here. We need to ask ourselves, why are we building SDNs? What is the primary driving force that is pushing us in this direction? Now, when we talk about SDNs, one of the things you hear a lot about is new network applications. So the idea of taking flows and cracking flows and doing things that networks have never been able to do before. And this is a very exciting topic. Certainly Dave mentioned that in his presentation, and we all are certainly looking forward to these new types of applications that are developed specifically to take advantage of this technology. But what we find with customers most often is the prime interest in SDN is not necessarily about these new applications, but it's the network agility and the ability to bring network agility in to be able to address use cases that are already there today. A lot of this actually revolves around provisioning. How do we bring, as Dave mentioned, how do we bring network into the fold to where compute and storage already is to address a lot of these new use cases that we find in application provisioning, new types of cloud services, and so forth. And so again, a lot of the interest that we find with customers is really around these current use cases and around network agility. The types of use cases that we find customers focusing on include things like public cloud, private cloud. So how do we build, sorry, the clicker's not working so hot today. How do we build network services as a service in a public or a private cloud environment? How do we support very high densities of tenants, applications, and so forth, and be able to manage that in a simplistic way? Dev test is another great example. We're hearing lots and lots of this from enterprises. How do we build a self-service dev test environment where a business unit or a developer within a business unit can come in, punch in a department code, request an infrastructure, and have that infrastructure turned up with network services in seconds? What we found talking to enterprises is that a lot of enterprises today test their applications without network services. It's either too expensive or it takes way too long to put them in place. So they build out these applications, and then when they move them into production with firewalls and load balancers and so forth, they find there's problems. So we want to address those challenges in those particular use cases. Now, IT automation is a broad topic, of course, but what we find is a lot of enterprises doing various aspects of automating different functions within IT. And even those enterprises that are more advanced, that have ordering portals where somebody can come in and order up storage and compute, when it comes to the network and the network services, usually those actions result in a bunch of emails getting sent off to a lot of really sharp network engineers who have to get in there and manually do things on firewalls and load balancers and routers and so forth. So we want to get away from that, and we want to have the ability that when somebody orders an infrastructure up, including network connectivity and network resources, that these things are put into play instantly. And DR. There's lots of opportunities in disaster recovery to do new things. As an example, take an entire application infrastructure, including network services, bundle it up, and move it to another location. And there's a lot of things that we can do with the technology that we've developed in Embrane. So the question then becomes, how does SDN help us achieve success in these use cases today? So let's take a look. Sorry, the clicker is not working up here. There we go. So where do we start? Well, a lot of the activity that we found in SDN is actually centered very heavily around Layer 2 network connectivity. Now, there is certainly that cross-section of customers that do have challenges around Layer 2, the scalability challenges, how to manage lots and lots of VLANs, and we've seen a lot of activity in Layer 2. But when we think about the use cases that we were just discussing, if the applications and the tenants are the focal point of these use cases, then they need a full encompassing solution. And it's not enough just to look at Layer 2, but we need to look at Layer through 7. We need to look at that entire network stack. we also have to consider how much disruption will we incur to try to adopt these new technologies. So if we start at layer 2, then if we swap out layer 2 and start including new layer 2 technologies, how disruptive is that to our environment? So again, we're looking at the full stack. Layer 3 through 7, and looking at that from the top down, gives us the quickest returns with the minimal amount of disruption to the environment. And if you think about it, layer 3 through 7 defines what we call a tenant. It defines the boundary between application tiers. So again, this is where we want to look to address. So this top-down approach, which is the Embrane approach to SDN, yields easily achievable benefits today. Now, Embrane our product is called Helios. It represents what we call software-defined network services, or SDNs. Okay, so this is the layer 3 through 7 approach to SDN. Now, Embrane's Helios delivers a robust SDNS solution that is actually in production today. And we do have this down in the lab, and it is certainly something you can come by to take a look at. All right, so let's take a look at, as soon as we can get to the next slide here, SDNS in a little bit more detail. So the first thing is, in our architectures, we start off with an SDNS controller. There we go. Now, the SDNS controller has this global view of all these network services that we're spinning up in the environment. It allows us to do things like push common policy out to lots and lots of firewalls, or push connection details out to lots and lots of VPN gateways, or look at things that are happening within load balancers. This service in the Embrane Helios product is provided by something we call the Elastic Services Manager, or ESM. Now, within here, we've also built a set of services that support this, and we call these services allow us to simplify the operation of these larger environments, these large multi-tenant environments. So we allow for that single pane of glass where we can look and see all the appliances that are distributed and deployed in these use cases. To that, we add another set of services which we call agility features. Now, the agility features are things that we're adding in that allow us, again, to take the network services component and have it better address these new use cases. So things like flexible licensing, pay-as-you-grow licensing, the ability to grow and shrink appliances non-disruptively, the ability to park appliances when you don't need them and then unpark them when you need them again later on. All of this fits within our agility feature set. Now, this sits on top of these layer 3 through 7 network services that we've been talking about. And the layer 3 through 7 network services in the Embrane model are called DVAs, or distributed virtual appliances. And these are virtual appliances that have the agility feature sets built in, that have this operational simplicity built in, and all of this rides on top of a cost-effective resource, namely x86 hardware. Now, to fit this into the model with a lot of the programmability and so forth, we've bolted on a capability that exposes all of this through full REST APIs. So we've built management applications, but the REST API interfaces into not only the controller, but also the services themselves, allows us to integrate this into off-the-shelf systems we see, like OpenStack or vCloud Director, but also allows us, which we predominantly find out there, to integrate this capability into a lot of the homegrown orchestration systems that we find out in service providers and enterprises. And that still today is the most common approach. So this architecture that we're looking at here is what we call SDNS. Now, the SDNS approach is very complementary to SDN. And the programmability that we're talking about here enables that integration into these types of solutions. It's designed for very high multi-tenancy, and it leverages low-cost x86 servers as its core resource. And SDNS rides on top of whatever you decide to do at layer 2, whether it's your traditional layer 2 today with VLANs, or whether it's taking advantage of the new SDN-type technologies that are addressing layer 2 scalability and manageability. And these agility features that I mentioned to, there's several of them there, but these are the ones that we've really built in, and this is sort of the sweet spot of this type of a solution, is bringing all of this agility into offering network services in these use cases. So let's take a look at an example here. Actually, my servers showed up there before they should. Let's take a look at a simple example, a self-service dev test environment. So the objective here is to build a self-service environment for testing applications, including network services. We want to do this with an easy management through some sort of portal. So let's bring the data center into the picture there. Now here I've got a couple virtualized compute pods and a very simple representation of a data center. Now the first component that we need to add here will be the SDN controller. Now the SDN controller, again, sees everything that's being spun up in the environment. As soon as it comes in, all right, it doesn't actually take that long to provision. It took longer on the PowerPoint slide than it actually takes to spin one up. So the controller is actually just a virtual machine, and it acts as the orchestration system for network services in the Embrane Helios model. Now, of course, we're talking about self-service here, so we need a portal, and we also need a higher-level orchestration system that sees all the resources that are there, the storage, the compute, and the network services, so that it can, when it provisions an infrastructure, it can provision all of these components. And then we need the resource pool that we're using for the SDN controller, and this is a pool of x86 servers. Now, the slide didn't build properly here, but those servers could be a dedicated pool, like we see here off to the right, or they could also be part of the resources within the actual virtualized compute pods. And in this particular case here, we'll use the ones that are sitting in the compute pods. We can add to that resource pool at any time. It takes seconds to add more x86 resources into building out these network services. Okay, so our developer is going to join us here momentarily. If anybody has some batteries, please see me after. So there's our developer. So our developer now wants to come in and order up an infrastructure. This person's going to test out an application and wants to put a certain application infrastructure into play. So they may need a firewall, a load balancer, and then some virtual machines underneath that might be web servers or the like. And the first thing they're going to do is they're going to contact this portal, and they're going to go in there and order up this infrastructure. And in doing so, the first thing that the orchestration system is going to go do is put the layer 2 connectivity in place. Again, this is not something that Embrane focuses on, but there are lots and lots of solutions out there on provisioning layer 2, be it traditional with VLANs or some of the new SDN type technologies. Once that layer 2 connectivity is in place, then the orchestration system will then go and provision those virtual machines, the applications themselves. Then the orchestration system would talk to the SDN controller, and it would say, I need a firewall and I need a load balancer. I need a firewall this big, and I need it inserted here in the network, and I need a load balancer this big, and I need it inserted in the network. The SDN controller looks at its resource pool, and it looks at the server capacity it has, it looks at the connectivity it has, and it provisions those services. And those appliances get provisioned down into the network and spun up automatically. Now, in this particular example, through a simple one-click, I could deploy, say, an HA redundant pair, a stateful pair of load balancers instead of a standalone load balancer. This is some of the things that we refer to in terms of agility services, the ability to one-click provision an HA pair of appliances. Now, once that's happened and that's been put into place, the developer then can access these right away, again, through that portal integration. So we can take the services that are represented by these appliances and expose them in a very simple fashion to the developer to configure them. So to configure the load balancer, the firewall, and so forth. So again, it's a very simple model. To spin this up, it's a total automated function. It's leveraging the full REST API capability of the Helios system to build this. And again, it enables things like one-click HA configuration. To build a DVA, once the system is in place, takes 90 seconds. And that's either a standalone appliance or an HA pair of appliances. That's a really hard thing to do today, not only with hardware appliances, but certainly with software appliances that are out there today. Now, what if this developer later wants to do some scalability testing in the application? So they need a bigger firewall. The same sort of flow would happen as we saw here to build the appliance. We'd simply talk to the SDN controller. The SDN controller would look to see where it has more resources in that pool to be able to expand the capacity of that appliance, and it would go ahead and do so. That function to do that is a 30-second process to grow a firewall or to grow a load balancer. And it's a non-disruptive function to do that as well. So again, we can provision the resources we need, and then if we need more resources down the road, it's a 30-second change. Now, finally, the developer has completed testing the application, but they want to store this environment because when Rev 1.1 comes out, they want to put this environment right back into play and continue testing. In this case, we would do what's called parking the infrastructure. So we would talk to the SDNS controller again, and we'd say, okay, I want to freeze that infrastructure and store it. The SDNS controller would take everything it knows about those network appliances and store it back on the controller so that it could be re-provisioned again in another 90 seconds. So again, this is the flexibility that we're looking for in the network and network services to support these sorts of use cases. So this is a very simple example here, and certainly if you come by the booth and come by the lab, we can show you quite a bit more in terms of the use cases. But new technology is fun, but we really have to keep our mind on the use case itself. And today, the SDNS approach, the layer 3 through 7 services approach, it yields immediate benefits today without disrupting your current environment. These use cases are real. They're here today. We're working with lots of customers on how to build these sorts of things, but they require fully encompassing solutions, not just focusing down at layer 2. So come by and see us, and we'll show you how these SDNS services work and how you might be able to leverage them in your environment. Thanks very much.